Okay, I'm gonna get this started. So, how's everybody doing? Good? Good? Woo! Good deal. So, quick introduction. I know it said two people, but I'm gonna introduce us both, and my partner's right here, obviously. So, he's a ninja. Like that. So, my name is Terry McCorkle. I am on the Boeing Red team by day and security researcher by night. Like to work on interesting projects, and I help out at a local hackerspace, Black Lodge Research, basically running education services for our community and information security stuff. Billy, who is not here, he works at Google Security, and he leads a team there. Prior to that, he worked at Microsoft, self-proclaimed supermodel, and right now he's in Hawaii at an all-hands, because that's how Google does it, apparently. I know. So he ended up going there instead. So just a quick disclaimer about what we're going to do here. This was an independent project that Billy and I came up with. We did it outside of work hours, did not use any of our employers' resources for this. Everything that we are showing you, we found on the, or that I am showing you, we found on the web. So it's all open source. And it's basically, what can you do, you know, all sitting home drinking beer on the weekends, right? So what are we going to talk about? Basically, like ICS, I'm going to go over industrial control systems, what they are, how they function, kind of some basic setups. Some research models that we actually did. I'm going to talk about how we found the software that we found, how we actually fuzzed it, what did we do to find these vulnerabilities. I'm going to tell a quick story about an attack path, so that you can get a better understanding of exactly how these vulnerabilities will be leveraged, and give you guys some ideas for future research. So why did we do it? Well, we were basically bored, and we were curious, and yeah, like usually when you put two hackers together that are bored and curious, like stuff happens. So the industrial control systems, when we started looking at it, or to understand it, it actually has two major components. So SCADA, which is what everybody refers to these days, is they're basically distributed control systems that reach over large areas. So they'll have wireless components and things that reach out. I'll get into this a little more later. Distributed control systems are more localized, so they'll be running a plant or something locally. And the big thing is they're widely used, and there's a lot of applications, a lot more than people know. Like average people, they really don't know, they don't care. They'd rather go through their lives and just, you know, let things work. They don't really pay attention. The average IT professional, on the other hand, they hear about this stuff occasionally. They hear about, you know, the IT incidents or the viruses that are attacking, you know, power grids or whatever, and they have a little bit better understanding. The reality is industrial control systems are used in almost everything we use today. They're used to make cars, they're used to make building materials, they're used in making everything that we use on an everyday basis. And these used to be things that were you know, controlled tight. They weren't on networks. We'll be getting into that. But basically these days it's evolved into something else. So data centers actually use industrial control systems for their cooling systems. So this is a giant HVAC unit. I just noticed there's a big block in my window. Let's try that again. Is that better? That's what I get for not looking at the slides. Maybe I should be a slide reader. Okay, so you have these giant HVAC units that are actually running the cooling systems and the AC systems for these data centers. Okay, there's some statistics out there, some studies that have been done. It's approximately 3 minutes 9 seconds before a data center's PCs actually start shutting down. I've actually been involved with this before. I've seen what happens when an HVAC unit goes out and you see the IT professionals running around the data center turning off machines. Okay, now when that happens, you know, who knows how to handle that? What do? You know, like I said, they run around, they turn off the machines. It's not necessarily a planned for event to have the HVAC unit go out. So when they're running around, turning off the machines and stuff, you know, you're losing all of your ability to actually perform business for that day. So think about it in that aspect. If your data center goes out, your employees don't really have much to do for the day, unless you're lucky and do something where they don't need it. So I understand some people don't care about data centers. Maybe they don't have data centers, and that's understandable. But here's another instance. So this is actually a Budweiser brewery distribution center. I got to take a tour, and I mean, they provide a lot of beer. A lot more beer than people realize. But if you look around there, you notice there's not very many people. The whole thing is run by control systems. Everything from the manufacturing of the beer to, you know, the actual packing and shipping and distribution of it. Right? I mean, those breweries are huge. They've got things in there that are looking the temperatures, that are monitoring the time it takes, all these things. So I guess my whole thing is, if you're not interested in data centers, maybe you think about other things, like things you enjoy, like beer. Here's their beer. So let's talk about a few of the components of an industrial control system. For this demonstration, I broke them into physical components and software components. Physical components, basically, you have MTUs or master terminal units that are talking through some sort of technology out to remote terminal units. You have PLCs. The PLCs actually control the ladder logic. They are what makes switches go on and off. And you have IEDs, which will sit out in the field and perform similar functions. They'll be doing the switching of on-off switches, things like that, but a lot of times they'll actually include things like website or web pages on them for control processes. So, you know, they're really intelligent. Software components. So the HMIs, which is what we kind of focused on, are basically what makes it go around. It's what they monitor. It's what people monitor, more specifically, to see what the control processes are doing. Data historians, they back up the history of what happened, what's going on. Control software and HMI suites, basically you have to have some ability to control what's going on the far end. So the HMI suites let you create these applications that let you see what's going on out in the field. So an example, basically you have, this is our brewery, okay, they're making beer. And you have an HMI, a historian, they're talking to the PLC, they're gathering data points, they're looking at temperatures, they're looking at what's going on out there. And they are what's making everything happen there. You upload and you download data to the PLC, and that's what makes switches go. So an HMI example, this is, for example, what an interface would look like. You got temperature monitors, you have your tanks, you have things like that. And they make beer. So a little larger picture, the SCADA portion of it. By the way, that last page was a distributed control system example. You'll have multiples of those throughout the factory or throughout the process. This is a distributed plant. Basically, you have same components you have your HMI and your historians and things like that. They're doing things, but you include things like an MTU, and they control some of the local stuff, but they may also have some remote things that are going out to these RTUs. Which, anybody seen anything that looks like that out in the fields before? So basically you have these RTUs out there that are then taking this information from the master terminal unit and making pumps go, or making whatever they do go. Again, you have the same paths going on there, talking back and forth, and it's just a standard thing. 1 second. So when we talk about security of these systems, the recommendation is actually to have them completely segregated. They shouldn't be on the local network. They shouldn't be on the local LAN. They should be segregated and completely separate. But that's not usually how it actually works, because you have to manage these systems. So they sit on the network, on the corporate LAN, and they have little users like Bob here, and Bob manages those systems. So it makes sense. But the other best practice is, if you actually can't segregate your systems, you need to have Bob using your systems, put a firewall there. At least do that. Make sure that only Bob can get to it. But, best practices is, listen, if everybody followed best practices, we wouldn't be in a job. So here's to not following best practices. So of all these components, the one that really stands out is actually the HMI. I don't know if you guys can see my laser pointer, but it's there. The HMIs are actually the interface that allows a user to understand what's going on that system. Okay, so of all these components, if you were connected to that switch, that's the one thing that you could get to through a web interface and actually see. So the biggest thing about the HMIs, they're accessible. There's something that you can get to. They're the user interface, so you can understand them. And they provide a gateway to all the other systems that are back behind the scenes. And the big thing that you have behind the scenes is proprietary formats. So you have an HMI which does this translation to these proprietary formats that aren't necessarily talking. They may talk over TCP, but they're not things that you're going to be able to just attach to and necessarily understand without a lot of analysis. And I know people have been working on those portions of it, but really it's a difficult area to understand and get into. Oh, and it's free. Like, HMIs are all over the web. So they're freely downloadable. You can go out and search. And this is where we came in. So we basically use search engines. We started looking around and figured out there's actually differences based on which country you're in. So different companies provide services to different countries. It kind of makes sense. So how do you actually go out and start finding this information on the web? If you're a researcher and you don't have any idea, what do you do? Well, here's a sample that I used actually, and this found quite a bit. So you can't read that really, but it says 3,600 results for just executables that are out on the web when you're talking about HMIs and download and file type exe. Okay, actually a lot of them end up being in zip files, so that's what you end up getting. So other examples include country names, include names of manufacturers that you're specifically interested in, things like that. You will find a lot of results that are out there on the internet ready to grab and play with. And also, I just have to put this up there, be careful. I mean, if you go to some fake download site, you can kind of pick those apart, I'd imagine, but don't download anything that's going to own your machine trying to do research. So my search really quickly found a few vendors. They're kind of all over the place. I only searched in a couple of countries, and I didn't necessarily do a thorough search. I spent probably 3 days looking for different vendors to play with. And that's kind of the smattering that I got. There's a lot more than this out there, so just as we go through this, be aware. So there's a big thing right now. Everybody's like, quit talking about SCADA. You know, why? Everybody's talking about SCADA right now. It's become the next big thing, right? And so we actually thought about that. We said, well, everybody knows it, but where's the proof? Where do you actually go find something that says, hey, here is the proof that there's problems within current day SCADA systems? And you find a few interesting tidbits out there. You find a few vulnerabilities that have been released, and you find a lot of people just saying how bad it is. Well, so we actually started looking at some of the manuals, right? Like you have instances where no special characters are allowed. They reset your password to 100, for example. Man, because that's a secure password. And you have examples where you'll go through a huge description of how the whole protocol works, but when you actually get down to it, you get lines like this. Let's say security is disabled by default. So there's actually nothing included. Or this one where they've just described a whole custom protocol with one line at the end that says there's no security. Actually, I love this. There's no security of this protocol. It's like barely even English. So, yeah, anyways, this is the sort of stuff you find. And then you start looking at their actual web forums, and you get things like this. Like, anybody recognize that? It was widely publicized earlier this year through like Stuxnet or something like that. I don't know. Anyways, so then you have like default passwords all over the place, and if you're interested in what those are or how these systems work, you can actually just go out to the web and look at some of their forums, and that's what you get. Tons of information, default passwords everywhere. So we set out to find some bugs, and we asked ourselves, how are we going to do this, right? Like, will we be able to just find bugs, you know, by basic fuzzing? So some of the techniques we looked at, we started with ComRaider because amazingly a lot of these systems still use ActiveX, right? And it's a common thing. It's known to be vulnerable in a lot of situations. You can write it securely, but you know, old school stuff wasn't written that way. A basic idea of what ComRaider does. You have a construct here that ComRaider knows how to look at, and then you build your string that you'll send to actually fuzz, okay, to see if you get a crash. And ComRaider looks for those crashes. You have file fuzz, which is very similar. It does bit flipping, so it'll go through and you give it a template file, and it goes through and actually builds a whole bunch of files to fuzz against, and then keeps track of the crashes as well. And Sully, which is a little more sophisticated, you can actually build out a protocol and say, I want you to fuzz this protocol, and I want you to fuzz it in this way. Okay, so even if it's a custom protocol, things like Peach and Sully, they allow you to build a custom protocol fuzzer. Okay, and I actually wrote, while I was at it, I wrote a program called blasty.py, and it's basically that. It just blasts a bunch of crap at services on a local system. The big thing about it is it actually focuses on, like, you can give it a range of ports, and it'll actually look at all of them while it goes through and look for crashes. Because we found bugs where you connected through, for example, port 8080, and if you did a fuzz through that, it would actually crash a different port on the system. Now, how do you see that unless you're paying really close attention? So this kind of gives, my idea behind that is that's what that is, and eventually I'm going to release it. I'm still working on it. So, and then we did a lot of manual analysis as well. I mean, going through the config files, going through the web configurations. So, some examples of what we found. This is an ActiveX control. We used ComRaider to look at it. It came up with this fuzz, and both of those strings actually crashed it. And when we ran some analysis on it, we found out that both of those strings crashed it, and that we overwrote EIP, which basically means that you have full control of anybody who connects to your website when they have that ActiveX installed. So armed with this fuzzing technique and some of the basic ideas, we went looking for bugs, and we found a few, just a couple. So overall, we found 665 bugs, and these are individual unique crashes. The thing is like, if you try to look for bugs and you get that many crashes, like understanding what they are and like distinguishing what is exploitable versus what is not it takes some intensive work. You actually have to get into every one, look at it, figure out if it's exploitable or not, and it's quite a bit of work. So basically, looking at it, we had the time to find 75 exploitable bugs out of that 665 crashes. So a few more than 100 actually. So if you break them in actually categories, we're looking at 204 ActiveX and 360 file formats and a whole bunch of other stuff that's just like, individual stuff. The manual analysis we did actually found quite a few bugs that were just written into the code, and you can find them that way as well as like SQL bugs. I'll get to it later, but like when I say SQL bugs, I'm not talking about SQL injection, right? Just SQL bugs. So what do you do with all those bugs? I mean, we have a ton of bugs, and what? Sell them, right? Yeah, okay. Yeah, we didn't want to sell them. We we like our day jobs, but one second. So I understand wanting to sell them, and I wish that was something I could do. But basically we looked at ICS cert. And not a lot of industries have this, but ICS cert does provide this service. They provide an interface to vendors in the industrial control system space. So let's face it, if you actually go talk to vendors and you bring a bunch of bugs to them, you say, hey, I broke a bunch of your software and it's shit, they say, well, here's my attorney, talk to him. And that's not what we wanted, that's not what we were after. So, and we also didn't want them having our direct contact information because, let's face it, that's not a good idea. So basically, ICS Cert actually handled all these vulnerabilities. We sent them to them, and they did an awesome job basically working with the vendors and getting them the information, and then creating a relationship between us and the vendor so that they can get fixed. So we have to thank ICS Cert because they definitely took on the brunt of the work when it comes to actually handling how the vendors see stuff. And the other thing is they let you, or they release your exploits as advisories to the customers. So ultimately, it's not just about finding bugs and exploiting, it's about making sure that people can get this stuff fixed, because as a researcher, I'm not just interested in finding bugs. I want to make sure that they're getting advertised to the people that need to know about it. So these are just 7 of them. We actually have a lot more coming. What's that? There's some detail in the releases. Probably. It depends on the release. But the majority of them, you'll get the name of the ActiveX control or the service that it was running on. And if you recreate what I just showed you as far as fuzzing techniques, you will find it. Right. So I know everybody wants to see the bugs. What? Real quick, before we get to the bugs, like I said, we just did fuzzing stuff, design issues, crap like that. Most of the shit we found was actually straight out of the 90s. It's old school stuff. It's not things that you would expect to find in today's software. We thought it was extinct. It's like, these are things that literally people used to find. So here's another buffer overflow example. Right? You have just straight up all of these methods are executable or are overflows. So a quick observation: we think they're using like agile programming. I don't know if you guys are familiar with this, but basically just write your shit. Don't worry about what it does. Don't worry about how well it's constructed. Another buffer overflow. So this one's a little longer, or a little bit bigger. You need a little more to actually get it to crash. But an interesting thing, I actually found this on the web. So it says the and the stack. That's kind of what you're doing. You're just sending a bunch of shit, and it's all overflowing onto the street. So I mentioned I'm going to go through an attack path so you guys can understand really what does this mean. If you got a bunch of bugs, it doesn't necessarily show how they're exploitable. So this is Bob again, and Bob connects to the HMI, and he works on the HMI every day. So that's his standard thing. And in this case, they've actually taken the ability to have a firewall in place. Okay, they've taken advantage of that. So only Bob can get to that system. All right, he's the only one that can get to the HMI. Let's see if my button works. So the HMI then is in this custom network that has the ability to talk to the PLC. All right, if you look at a PLC, this is kind of how it really looks out in the field. Okay, you have your PLC, it has all these cables going to different relays and switches and motors and things like that, okay? And it's using ladder logic to determine what's allowed to do what. But if you connect to that PLC as just a standard attacker and you have no idea what it does, which relay do you flip on? What do you actually do in order to make this have some effect on whoever it is you're looking at? So when you consider something like this, attacking the PLC directly is a very difficult thing to do. Now something like this, on the other hand, this gives you access to an actual HMI that gives you the pumps and the switches. You can get an idea of how it's laid out. You can get an idea of what it actually does. Okay, so this is what you get when you connect to an HMI, which is mainly why we focused in that area. So with an ActiveX control that's vulnerable, Bob found something really exciting, and he goes out to the internet to tell all of his friends. This is a real forum, by the way, and people do post all sorts of interesting stuff there. But the thing is that you have people who work on these systems frequenting these sites. Okay. I pulled the slide, but there's actually vulnerabilities in those sites too. So imagine that. So anyways, you got somebody sitting out there that's waiting for Bob to connect. Okay, they found some vulnerability in the system, and that allows them to get to the HMI, at which point they have access to his config files, his PLC data, all those control points. They can actually look at that point and tell what it actually does. So if they wanted to cause an impact, they now have the data to do so. Okay, and they have access to the machine through the person that actually has access to the PLC, or through the PLC to other systems, even if it's protected. I mean, a lot of times you'll have just one port open, and maybe not a lot of times. Anyways, so some of the interesting bugs we found, we just kind of chalked them up to what were they thinking. Here's an interesting one. This is a SQL command bug. It's through a SOAP service, and the SOAP service just lets you submit any SQL you want. So here's our SQL. We want to see all of the users. Show me all of the users in your custom proprietary database that has probably never been assessed by anybody. And what you get back is a whole bunch of users and a whole bunch of really interesting things to look at. So what do you see when you log in as these people, or what do you see when you get these lists and actually start looking at their access lists and things like that? There's another interesting one. So this is a command, or this is a control that is built in. I don't know if anybody memorizes class IDs, but if you do, you'll know what this is. But this control actually lets you run an exec shell. It's built into Windows. It's a Microsoft ActiveX, and it's always there. But In this case, like this vendor decided that ActiveX, which is usually not safe for scripting and not safe for initialization. Real quick, what that means is safe for scripting basically says that you can write a script through VB script or something like that and actually include that ActiveX as part of that script, and it'll work, okay? Safe for initialization means it loads with Internet Explorer when you connect to the internet. So in this particular case, this vendor decided that that should be available to the internet and safe for scripting, and people should be able to execute commands from the internet, because that's the way it rolls. Nothing at all. Nothing can go wrong. Exactly. Here's an interesting one. So this one here, the control actually, it's an MSI file, and it's a silent install in the background, so there's no pop-up, there's nothing. And the thing is like, okay, I can understand them needing to update their software or whatever they're going to do, but there's no specification that it has to come from a particular site. So as long as you name your MSI this name, and you include it as a control, it will download and install your MSI, silently. Quickly, just a comparison we came up with of this ActiveX versus like malicious spyware crap that you're going to download off the internet. Hey, malware is going to find some exploit. It's going to exploit it. It's going to mine bitcoins with your machine, and it's going to profit. This machine, like just download this make sure this person has this ActiveX, run this command, and you mine bitcoins with their machine and then profit. So it's an interesting place to be. Oh, here's one, because everything should be able to read the registry from the internet. It's it's a useful function. So they include things like file exist, registry read, registry write. That's useful. And then they also have the shell execute as well, built into their ActiveX. So one of the really interesting ones, actually, this is just, you have to set this up in order for it to work. So there's some caveats, but basically this site gives you the ability to add yourself to trusted sites. Okay. So, and really, like, okay, so you're added to trusted sites, what can you really do with that, right? And you look at the WScript shell command and stuff, well, that's not available, is it? Right, that's totally restricted, you can't do that. And you can't, you don't have the rights to actually make that happen, which is totally true. Usually you don't, unless you do this, which also happens when you install the software. And anybody who's familiar with this, basically what you're saying is the .NET framework is now added to the trusted sites. So anybody that is a member of the trusted sites can call executables or functions from the basically from the .NET framework. Okay, so yeah, not very difficult to deal with, and don't worry, it's okay. It's fine. Nobody's gonna bother with that stuff. So you'll be okay. So overall, I mean, we went through a lot of things. We looked at a lot of stuff. We looked at 48 vendors, or I should say, we downloaded software from 48 vendors. We looked at 76 of the 380 applications that we downloaded. So just to give you an idea of what we're really looking at, I mean, we did not touch a whole lot of stuff. Actually, maybe 20% of what we found on the web, we actually looked at, mainly because we ran out of time. I mean, let's face it, nights and weekends, it's a lot to look at. So if I was to say to people, like, what other things should we be looking at in this space? What are the things people haven't considered? Well, we found a lot of design problems, right? Just in general. A scripting language, they provide a lot of custom scripting languages for these applications. And who knows what they can actually do, their capabilities. OPC, That's interesting. It's basically a connector between a proprietary format and DCOM. But if you go out and start reading on it, there's actually some really interesting things, because guess what? OPC doesn't work on anything like with standard Windows security model, because you have to be able to talk anonymously to OPC, that sort of thing. So it really gets interesting. There's custom databases that are interesting, protocols, like all these things that we definitely didn't get to look at. We looked at the HMI specifically. We didn't look at the services. We didn't look at all these other things. And we didn't get to look at mobile. So, like, if you start looking at mobile, now, because it's the craze. Everybody wants a mobile app. Everybody wants something that works. Like, this guy came up with one. And he produced it on the Apple Store, like, hey, this is cool, because everybody needs to be able to control their pumps and switches from their iPhone. Right? So now take everything I just talked about and put it on a phone. What can possibly go wrong?
Where does he live?
I don't know. So basically what I want to leave you with is looking at this data that we found and all the issues we found just in looking at a cursory look, right? Do people know where their ICS assets are? Do they really know if they're using? And we can tell them. You're right. But do most people even have a clue they're using industrial control systems with these vulnerabilities? Because, how critical is it to your business? Like, you install a factory line and you're running things and you're building widgets or whatever, and maybe you make chemicals or something like that, right? Like, this is an example of a plant that they made chemicals, and they accidentally had two chemicals that weren't supposed to mixed together, and that's what happens. So how critical is it to your business that you actually understand what's going on with these industrial control systems and what they're doing, right? Now, this is a pretty extreme case. Luckily, nobody got killed in this, but what do you think their cost is for that business?
Insurance covers it.
Insurance covers it. You're right. You're absolutely right. I bet their insurance goes up. So really, how are you protecting your industrial control assets? Are they firewalled? Are they segmented? Do you patch them? The majority of the cases I've seen, they don't even get patched, because the IT doesn't want anything to do with it, and the industrial control systems engineers really don't have a clue about a computer. They're very smart. They work with ladder logic excellent. They can make HMIs, but they don't necessarily know how to patch a machine.
Sometimes they don't want IT touching.
Exactly. IT leaves this stuff alone. There's that too. There's a lot of things that create this. It's bad software programming combined with a lot of just standard environment, issues, standard corporate issues, and So basically, that's what we had. We want to thank ICS for actually juggling all of our vendors. I'm calling it juggling because I'm sure that had to be a pain in the butt to do. We found this across a lot of different vendors, and they did a great job.
So OCS, ICS are just recently classified as design error that's no longer considered a security vulnerability. So like 500 homes that were undisclosed just disappeared.
Did they really?
Yeah.
I didn't see that, but that's really interesting.
They've gotten a lot of criticism over the past 2 weeks.
So to comment on that, the SQL vulnerability that we found, that's being argued as it's a design,
Right.
and it's probably not going to get patched, but we'll see what happens. You're right. It's not going to get a classic patch. All right. Sure, absolutely. We will be coming out with a whole bunch of stuff. Corland's developing a whole bunch of exploits for us. So, and Metasploit's going to be publishing them. We have a couple. Actually, some of these bugs Egypt took to his class, and they're going to be doing that. So I definitely give a big thanks to Corland, because with all these bugs, I mean, how do we actually have time to deal with that and write exploits for all that? And then Metasploit is awesome. I mean, come on, let's give it up for them. So real quick, this NIST document, if you want to learn more about industrial control system security, this was published earlier this year. I'll try to make this available on the web. But basically, I know this is available on the web, obviously. But basically, the NIST document goes through, it's really long, but the first 20 or 30 pages go into really good detail on industrial control systems and how to protect them, and some ideas on what you can look at. So, you know, ICS has a website, Corland has a website, Metasploit has a website. So, yeah, that's it.
NIST has the 853 controls for scada supposed to be announced, delivered